Hello, this is the 2021 General Math Exam 2 question 4 of networks. So we have roadworks planned by a local council with 13 activities to be completed with their activities and completion times in weeks shown. What is the EST of activity K? So K is this guy over here. So the earliest possible time I could start K, so we want to find the longest routes to get to K. So it's going to be either BF to get there, or BC, EJ, or AEJ. Those would be all the routes prior to activity K. So BC would take 5, so A is longer, so it's 6 plus 5 is 11 plus 3 is 14, versus the 8 of the BF route. So 6 plus 5 plus 3, 14, so the EST of K is going to be 14. Okay. How many of the activities have a zero float? So we wanted to find the length of the critical path. So we have A, E, J, and then K would be 17. So I'll just make a note of that. And then we have, again, we're not going to consider BC because A is longer. And then we're also not going to consider BF because, you know, the A, E, J route is longer. So 6 plus 3 is 9, plus 4 is 13, plus 5 is 18, plus 1 is 19. So there's a 19 there. Okay, and then we also have an AEH, so that's going to be 6 plus 5 is 11, plus 2 is 13, plus 5 is 18, plus 1 is 19. So it looks like we have two paths that have a duration of 19, and it looks like that's going to be the longest path through the graph. So we've got 3 and 4, which is 7 through there, 5 and 2, which is also 7, so that checks out. The A, and then it's the LM, looks to be the two critical paths. Meaning, the number of activities with zero float is 1, 2, 3, 4, 5, 6, 7. So all of the correct activities on the critical path have floats of 0, so there's going to be 7 of those. Certainly a little bit tricky, I guess. We'll keep a note that that duration was 19. It's also handy to note that the duration of the other route we found was 17. That's pretty close if we have to do some crashing. Alright, it looks like that we're doing this straight away. Okay, so it is possible to reduce the completion times for A, E, F, L, and K. We have costs for them. The completion time can be reduced by a maximum of 2. The overall completion time can be reduced to 16. What is the minimum cost of the change in completion time? So we want to bring it down to 16. Question like this, it's going to be beneficial to write down the routes through the graph. So we'll do that. So it's going to be A, D, G, L, M, and then A, E, H, L, M. We also have A, E, I, M. And then we have A, E, J, K. Trying to approach it systematically. So we've done all of them once to start with A, it looks like. Then it would be B, C, D, G, L, M. And BC, EH, LM. We'd also have BC, EH, LM, BC, EIM. And then BC, EJK. So basically the same as the other route, it's just instead of starting at A, which started with BC. And then we also have BFK. So there's a few routes through this one, which makes it tricky, that's for sure. The ADGLM route we know is 19. The same is true for the AEHLM route. The AEIM route is 11, 12, 13, 14. AEJK is 6 plus 5 is 11, plus 6 is 17. The BC routes are all going to be one shorter than all of those, because BC takes 5 to get there. So it's 1 less than all of those. So that would be 18, 18, 13, 16. You could just calculate them if you wanted to, but I don't want to. And then the BFK was 3 plus 5 is 8, plus 3 is 11. I think we found 17. Yeah, there it is, AEJK. AEJK, yeah. All right, that seems fine. All right, so we want to bring all of these down to 16. That's fun. So we're going to start with the two critical paths, the 19s, and we've got to reduce something on those. A, E, F, L, K. A will do both, L will do both. That's it. So I guess we start by reducing L by 1. And if we reduce L by 1, we get, this is messy, I probably should have done this on another page. If we do L by 1, we'll get 18, 18, 13, 17, and this will become 17, 17, 13, 16, 11. And then it looks like, you know, the paths that were critical again critical, so we're going to reduce L by another one. So that would make that 17, 17. And then that would become, that shouldn't have reduced actually, that shouldn't have, that should stay as 14. I'm going to write the ones that didn't change, I'm just going to not change them. And so that's now both 16, 16 for those two. That one won't change, that one won't change, and that one won't change. So, again, we want to get it down to 16. We've done L by 2, that's our only choice. And then we've got still the root that's 17 that's holding us up, that's top root, but we also have another 17 now. So we want to reduce all of those roots by 1, and we can do it by reducing A by 1. So it looks like reducing A by 1 will bring that down to 16, and bring both of those down to 16, which is going to meet our requirement. So we've done L by 2, A by 1, so 2 of those, 1 of those. So it's going to be 140 plus 240 is going to be 380,000. So again, certainly tricky. Probably should have done that on another page to be clearer, but the same general approach is fine. You could likely do that question by looking at the graph and not doing it with the big long scary table, but it's generally a pretty safe way to approach these questions. So you just, again, you want to start by reducing any activities that are critical, and if you can reduce all of the critical paths at the same time, that's generally a good idea. It's, you know, it's sort of optimized. So I started with my two 19s. I saw that I had either A or L for both of them, and then L was the cheapest, so do that. Reassess, it worked out that L was the best again, so do it again, reassess, and then it works out that A is going to reduce the last 3 all down to 16, so we do A by 1. So 2 by L, 1 for A, 380,000. Certainly tricky, but yeah, hope that makes sense, hope it helps, and I'll see you in the next one.